All right, so guys, today is our 17th session, and today's our topic would be IPv6. Okay, let me start here. IPv6. So before I start IPv6, I just want to confirm and I just want to know few things. Those whose IPv4 is clear, please raise your hand. IPv4 addressing and IPv4 subnetting, please raise your hand. Okay, so who is this? 34575788. Who is this? Him? Brother, what's your name? Like, I'm not able to see your name. Your number is showing here. 3457. Can you please say your name, please? Hello. No audio. Okay, no worries. Stephen says his IPv4 and subnetting is clear. Okay. Apart from Stephen, who else whose IP addressing and subnetting is clear? IPv4 addressing and subnetting is clear. Because people thinks that IPv6 is very difficult, but I will make sure you guys will be able to understand it very clearly and in a very simple way if your concept is clear in IPv4. I will just correlate it with IPv4 and I will try with my level best to make you understand the entire concept of IPv6, which is very simple. Okay. So if your IPv4 addressing is complete and it's clear, trust me, it is IPv6 is also very simple. Okay, so what about Saurav, Raju, Pratmesh, Parmeshwar? Yes, Parmeshwar, you are not saying something. Kapil, guys, say something. Hello.
Yes, sir.
Yes, so your IPv4 addressing and subnetting is clear or not?
Yes, sir. Clear. This first time class.
Okay. All right. So I'm doing one thing. Today, I'm going to cover the theory, the entire theory part of IPv6. And tomorrow, we will come into the IPv6 subnetting part.
Okay.
Okay. So for like 24 hours, you will get the time to understand about IPv4 addressing and subnetting. If you are not clear, if you're not aware about that, just take your 24 hours and complete your like knowledge in IPv4, complete command on IPv4 addressing and subnetting so that you can understand the IPv6 subnetting as well. Okay, it's simple. It's
Okay.
just like IPv4. IPv6 is also simple. Okay, so before I start further, let me turn off the annotation. Mm, okay, now, so we know that IPv4 is of 32-bit and IPv6 of
128.
128-bit, right? First of all, we will understand the similarity and dissimilarity in IPv4 and IPv6. What are the similarities and what are the dissimilarities? Okay. So very first thing, okay, before similarity and dissimilarity, let me discuss something on the like concept of IPv6 so that you can understand. So what we have here, IPv6, IPv4 is of 32-bit and IPv6 of 128-bit. IPv4, how we indicate IPv4 in a dotted format, right? Like 192.168. something like that, correct? IPv6, what about IPv6? This is dotted format in decimal, okay? And this is hexadecimal separated by a colon. hexadecimal separated by colon. How to convert a binary to decimal to hexadecimal? Everyone knows that? Everyone knows that? Guys, if you don't know, please say. I don't have any issue, I don't have any difficulties to make you understand or to explain a simple thing. Okay, if you don't know, just tell me, no need to hesitate. Just tell me, yes, I know.
Actually, yes, please tell me, sir.
Okay, so conversion also I will explain. Okay, before that,
Okay.
let me explain this. So as of now, IPv4 is in decimal format, and IPv6 is in hexadecimal separated by colon, right? Now, in IPv4, we use subnet mask. In IPv6, we do not use subnet mask, but we use, you say CIDR notation. CIDR notation that is equivalent to subnet mask in like IPv4. We also use CIDR to indicate the subnet mask, right? But in IPv6, we do not use any subnet mask, whereas we will use CIDR value. All right. In IPv4, we had broadcast address. In IPv6, we do not have any broadcast concept. Okay. So here we had the concept of broadcast. In IPv6, we do not have any concept of broadcast. We have anycast. Okay, anycast and multicast. Done. What else? If I'm leaving something, no. Yes, and in IPv4, we had the concept of private address. In IPv6, we do not. We have the private address, but we do not need the private address. Each and every single PC in the world can get the public address. So if I am using a public address in the each and every PCs, what does it mean? Here, NatPat concept is gone. No more need of NatPat. Okay, because why we use NatPat? Why use NatPat? To convert the private IP address, to translate the private IP address into a public IP address. So when the entire PC is getting a public IP address, then why we will require the NatPat, right? So that is why NatPat concept is not there in IPv6. Is it clear as of now? Is it clear as of now?
Yes, sir.
Good. Now, these are the differences. You can say these are the dissimilarities. What are the similarities? What are the similarities between IPv4 and IPv6? The first, you can say, as both are IP address, so this is the common sense, like both works on layer 3 address. Okay, so both are L3 addressing. Okay, the second similarities, you can say, both have some network and host portion. You will get the CIDR value like 48, 64, something like that. So as per the CIDR value, you can identify the network portion and the host portion, whether in IPv4 and IPv6. No confusion in that. Done. The third similarity, you can say, both IPv4 and IPv6 dependent on layer 4 for other functionalities. Okay. If you talk about the concept of OSI reference model, the same thing whatever we had in IPv4, The same thing, the same functionality would be there in the IPv6. No changes. Okay, just the format is getting changed from IPv4 to IPv6, but the functionality would be the same. Okay, done. Now before I proceed further, because we also have few new members, so I hope, I think that hexadecimal to decimal and binary conversion is not clear to everyone. So let me complete that first. Just it will take few times. So let me open the new page. Okay, now, so first of all, we all know that binary to decimal conversion or decimal to binary, we will not go into the schooling concept, whatever was there in the schooling concept. So because in IPv4 we just need the value till 255, so we have the binary scale, which is say 1 2 3 4 5 6 7 8. We know that. I'm talking about IPv4. Those who don't know the conversion, for them I'm just explaining how to convert the binary to decimal and decimal to binary, and then we will come to the hexadecimal. So it will not take much time, so just get the concept clear. Okay, now we have 8 bits. In IPv4 we have 32 bits, which is divided into 4 octets: 1 2 3 4. Okay, 1 2 3 and 4, here here and here. Each octets will have 8 bits: 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, and that is separated by a dot. Okay, now each 8 bits value, if you like observe, the value would be in between 0 to 255 of each octet in IPv4 address. So how it comes? We have 8 bit: 1 2 3 4 5 6 7 8. The value of all the 8 bits is 1 2 4 8 16 24, sorry, 1 2 4 8 16 32 64 128. If I say 240, what does it mean? 240 means 128 plus 64 plus 32 plus 16 is equal to 240. 128 plus 64, 192 plus 32, 224 plus 16, 240, and then this would be off. 1 indicates on, 0 indicates off. Same if I have this binary, or say the binary 10101010. If I want to convert it into decimal, this is what, if I say 240 is a 240 is a decimal, I want to convert into to binary, so this is the format. You can convert it here. If I say this is the binary, how to convert it to decimal? We know that the value of 8th base is 128 plus 0 is off. What is this? 128, 32 off, 16 on, 16 plus 8 off, 4 on, plus 2 sorry, okay, 128, 32 off, 16, 8 off, 4, 2 1, right? Am I right? Sorry, 2 8.
सर 16 की जगह 32 होगा.
Okay, sorry. Yes, 64 32 by mistake. So 128 plus 32, 160 plus 8, 168 or 2, 170. 170 would be the decimal for this binary. Okay, so this is the easiest way to convert a binary into decimal and then decimal to the binary. Now let us come to the IPv6 concept. We have hexadecimal. What does it mean? What does it mean? Hexa means 16, right? So here in binary we have the power of 2. Okay, we have a power of 2, 0 and 1, but in hexadecimal the value would be 0 1 2 3 4 5 6 7 8 9. After 9, in decimal, if it is 10, we indicate it as a A. If it is 11, we indicate it as a B. If it's 12, C, 13, D, 14, E, and 15, F. Yeah, it's very simple. If you have something in the mind, just blank your mind. I'm just making it very simple, okay? Now, if I'm saying, and one more thing, in hexadecimal, we will indicate like, we have 128 bit in hexadecimal, 128 bit in hexadecimal, that would be in the group of 8 groups. So if I'm creating 128 bits and indicating it in 8 groups, it means in a one group, how many bits are there? How many bits are there? I am breaking 128 into 8 groups. So in one group, how many bits would be there? Guys,
8.
if I have, one second, if I have 128 bit, I am breaking it into 1, 2, 3, 4, 5, 6, 7, 8, separated by colon. Okay. If I am breaking this 128 bit into 8 groups, in one group, how many bits would be there? 8
16.
or 16? Yes.
16.
Okay, who is this?
16.
There will be 16. Yes. So in one group, we will have 16 bits. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. We know that group of 8 we called as octet. So group of 16, what can we say that? If a group of 8 known as octet, the group of 16 can be known as, we know that group of 16 hex, we can say hextets, right? So in IPv6, we will indicate, brother, who is this? Please mute your mic, brother. Okay. Now, from now onwards, we will say every group in hexadecimal in IPv6, we will say as a hextets. Okay. Now, hextets has 16 bits in one group, in one hextet. One hextet, we have 16 bits, right? The value of 16 bit is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0 to 15. Okay. So 0 in hexadecimal, 0 will indicate at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then, sorry, 9, after that A, B, C, D, E, and F. So if I am counting from 0 to 15, what does it mean? If I'm counting 0 to 15, what does it mean? In binary, in IPv4, we have a binary scale from 0, 1, 2, 4, 8, 16, 32, 64, 128, which was combining all together to make 255. But here we only have to reach 15. So why would we require these things? Not required. If I'll count this 1, 2, 3, 4, 8 plus 4, 12 plus 2, 14 plus 1, 15, right? Right? So we learned, like till date, we know one bits is one character is equal to 1 bits, 8 character is equal to 1 bytes. We know that. We know that one character is equal to 1 bits. 8 bits is equal to 1 bytes. You can say, correct. But in between this, we have 4 bits. We know as 1 nibbles. Okay, so we will call this as a nibble. So here we have 16-bit and we will combine that into 4 nibbles. 4, and the 1 nibbles value can be vary from 0 to f, means from 0 to 15. Am I clear till now? Am I clear? Any confusion in understanding this?
No, sir.
If you see any
Yeah, I'm
IPv6,
confused. I'm confused, sir.
yes, what is your confusion? Where is the confusion?
Um, in the nibble, the part of the nibble, the four nibble. Yeah. Thank you very much.
One character, we know that. We know bits, bytes, kilobytes, megabytes. This is the format, right? Till date, we know one character is equal to 1 bits. There is no confusion. 8 bits is equal to 1 bytes. There is no any confusion. Correct? But in between 1 bit and 1 byte, we have another value that is called 1 nibbles. What is the nibbles? 4 bits is equal to 1 nibbles. Clear? So if I have in IPv4, IPv6, in one group, if I have in one hex state, if I have 16 bits, if I combined, if I convert into nibbles, we can say we have 4 nibbles, right? 4 nibbles. And the nibbles one, what does it mean? If whenever you will see any IPv4 IPv6 address, you will see like this, FE08 colon 2004 colon D634 colon something like that, right? So you will never see a value more than F, right? In hexadecimal, the value can be in 1 nibbles, the value can be from 0 to 15, not more than that. From 0 to F. If you convert into the decimal, it will be from 0 to 15. Clear? Is it clear?
I'm
Gagan?
clear. I'm clear now, sir. Thank you.
Okay, now, so let me clear this. Mm, now, as we know that in one hex stats we have 16 bits. 16 bits means 4 nibbles. If I combined, suppose if I'm saying, now just try to just learn how to convert a hexadecimal to binary. If I am saying again, I'm saying you, please do not take any pressure while converting. I'm just teaching you the conversion just for the sake of knowledge. This is not mandatory. This is not, yes, it is mandatory, but this is not as much mandatory so that you can take pressure and you will start converting each and everything. Okay. In IPv4 address also, I told you that binary to decimal conversion is required, but do not take pressure and do not try to convert each and everything. The same thing here as well. I'm just teaching you just for the sake of learning, just for the knowledge, but do not start converting each and everything into the any hexadecimal format to the binary and decimal. Okay, that is not required, but to know it's good, it's important, and it's necessary. Okay, so now say I'm just taking only first hex set and the value is FE08. Okay, In IPv6 address, we have F08 and then rest would be 0000. Just to make you understand, okay? Suppose this is the IP address we have. Okay, something. Now, I'm just taking this thing, okay? FE08. If I have this value in the first hex state in IPv6 address, if you want to convert it into the binary, okay, we know that this four thing is what? This is 1 nibble, 2 nibble, 3 nibble, 4 nibble, right? 1 nibble means we have 4 bits here, 1 2 3 4. We have 4 bits here, 1 2 3 4. We have 4 bits here, 1 2 3 4. We have 4 bits here, 1 2 3 4. Now if I talk about the decimal, this is hexadecimal. FE is a hexadecimal. If I convert into the decimal, 8 will be 8. This is the hexadecimal. What would be the decimal? 8 would be 8, 0 would be 0, E would be 14. Here we have E would be 14 and F would be 15. Done. Now if I convert 15 into binary, we have binary scale only 1 2 4 8. No need to go to 128. Okay, we have only 4 bits here, so we will take only 1248 as a binary scale here. So 15 means what? F would be converted into 1 2 3 4, 8 for 12 14 and 15. Done. E would be converted into binary as 14. 40 means 8 would be on, 4 would be on, 2 would be on, and 1 would be off. 0 means all 0, 1 2 3 4. 8 means 1 on, rest all would be off. So if I convert this as a binary, this would be the value. Any confusion in understanding this? Any confusion, guys?
No, sir.
Is it clear for everyone? Simple, no rocket science.
It's clear, yeah. Clear, sir.
Okay, so how to convert a hexadecimal into decimal, or how to convert a hexadecimal into binary? It's a simple, no rocket science. It's very simple. Take another example just for your practice. Say we have let me clear this as well. We have a value, say 2E9F. Okay, 2E9F. Okay, what would be the decimal? If I talk about, this is the 4 nibbles we have in one hex state. We have 4 nibbles. If I talk about the first nibble, what would be the decimal format of 2?
0010.
I'm talking about decimal. This is in hexadecimal.
0010.
Brother, please listen to me carefully. This is in hexadecimal format, right? If we have alphabets, that is means
Two.
okay.
Yes.
So I'm converting into the decimal. So 2 means
All right.
2.
2.
2,
E means
14.
9 means
9.
9,
F means
15.
15. So this is the
15.
hexadecimal. Okay. Sorry, this is the decimal. Now, if I convert into the binary, 2 means what?
0010.
0010. Very good. 14 means
1110.
1110.
1110. Very good. 9 means
0111.
1001. And 15
Yes.
means all one.
1111.
Simple, right? So if you want to convert a hexadecimal to binary, you can convert that. If you want to convert a decimal into hexadecimal or binary, you can do that. It's simple now, right? Clear? No confusion? Anyone? Is anyone has any confusion? No? Guys, say something. Yes, no, maybe.
No, 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 no,
No, no,
no,
sir.
sir.
No, sir.
Good. Now let us come to the next page. Okay. Now we will learn about how to shorten, how to shrink the rules of shrinking the IPv6 address. As we know that it's a very long address, 128 bits is very long. So how to short that, how to shrink that. So those who are making notes, please note down rules to shrink or short any IPv6 address. Okay. The first rule is we can remove the leading zero. We can remove the leading zero from all hex states. Okay. We can remove leading zero from all hex stats. Done. There is basically only two rules to shorten or shrink the IPv6 address. The first rule is we can remove the leading zero from all hex states. What does it mean? If I have say fe08 colon 9e04 colon 008 e colon 5e90 colon 600 d colon 000 e colon and 0001. Okay, 1 2 3 4 5 6 7 and 0015. Okay, so this is the value we have. Now if I want to shrink that, the first rule was we can remove the leading zero, means this would be a same f. Let me change the color. Yes, fe08 colon 9e04 colon, this is the leading in this hex state, right? So we can remove this. We can write 8e colon 5e90 colon 600d colon. We can remove this, just write e colon. We can remove this, just write 1 colon. We can remove this, right? 15. Done. Any confusion? No.
No, no, sir.
Good.
No, sir.
Now the second rule is you can say we can remove the successive field. If we have any successive fields of 0, then we can remove that with the indication of double colon. Okay, you can write that. Yes.
सर एक क्वेश्चन पूछना था मुझे
हाँ हाँ
जैसे हमने इसको श्रिंक कर दिया
हाँ जी
0001 को हम श्रिंक करके खाली 1 लिखा हमने
हाँ हाँ
तो एक्सपेंड करना हो इसको
हाँ
तो
हाँ
एक्सपेंड
exactly. So if I'm writing suppose e, okay, if I'm writing e or suppose 1 or suppose 15, we know that this is a hex state, right? This is a hex state. So e means what? All the previous success like all the leading zeros has been eliminated. We are not removing the following zero, we are removing the leading zero. Okay, this is the rule. If you will remove the following zero, then there will be the confusion. Okay, now e means what? It is 000 e. 1 means what? 0001. So if you will convert, this is the hex state. In the first nibble we have 0. So if you convert into binary, 0000 again 0000 again 0000 E means 14, 0, 8, 12, 14, 0. This is the binary. Then for 1, what would be the binary? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Okay. You will understand this as a nibble, means 4 bits. Okay. Every single character in hex state is equivalent to 4 bits. Okay.
Okay, sir.
Any confusion now? We are having 15 here. It doesn't mean the value is 15. Okay. We are having 15 here. It doesn't mean we have a value 15. What does it mean? What does it mean? In first nibble we have 0. Suppose I am converting 15. We have this. The first nibble 0 means 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4. This again 0, 1, 2, 3, 4. Then 1, 1, 2, 3, 1. And then 15 means 1, 2, 3, 4. So that would be the binary.
Hello.
Yes.
Please, sir, I have a question, sir.
Yes, please.
Sir, ये 15
Please, sir, I don't understand. Who is here leading? See, let's
Sir?
assume that you are
आवाज आ रही है?
Dear, your voice is very low. Boris, your voice is very low. I'm unable to hear you.
Hello, sir. Hello.
Yes. Yes.
I'm saying that I'm a little bit confused.
Where confusion? Where exactly your confusion is?
Sir, about the leading.
Uh-huh.
So that we can remove the leading 0 from all the.
Again your voice is low, brother. Again your voice is low.
सर मैं ये कहना चाह रहा हूँ ना ये
Can you hear me now?
One.
Hello?
Him just hold on. Yes.
Hello?
Yes, Boris.
Yes, I'm a little bit confused, sir.
Yes, tell me, where is the confusion?
About the leading 0 from all the X, where you are remove the 0. You didn't remove the 0 from 6, 0, 0, D. You maintain it.
This is not the leading one. This is here we have 0 in between 6 and D. This is not the leading one. We are just removing the leading zeros from here. These two are leading one in this hex states. These three are leading one in this hex states. These three are leading one in this hex state. These two are leading one in this hex states. So we are removing only the leading one.
Okay. Thank you, sir. Okay, thank you, sir.
Okay, if you will remove this, how will the machine or the system will understand like you are removing 0 from where? So that is why this rule has been made. Only the leading 0 can be eliminated, can be removed. Okay.
Okay, sir. Okay, sir. Means
Yes.
that the lead that is the first 0, the first 2 0
Uh-huh.
who's coming before, or if I understand the rule.
Uh-huh. What when in this is one hex state, in any hex state, whenever 0 is coming earlier, you can remove that.
Okay, thank you, sir.
Okay, done. Now
Okay, yes, sir.
yes, him, what is your question?
सर मेरा कोई क्वेश्चन नहीं है सर जो आप 15 कह रहे हैं ना 15 नहीं होगा 115 होगा सर वो
0011 सर
15 अगर आप बोल लेते F होगा सर उसमें ना
नहीं एक मिनट, ये वाला ना 0015 में ना
एक
यार,
सर
आपने नीचे में जो है 15 का 15 का कन्वर्ट कर रखा ना आपने
हाँ तो
1 15 नहीं होगा
समझा नहीं, ये 0015 को मैंने कन्वर्ट किया ना, ये हेक्साडेसिमल में था, इसको मैंने बाइनरी में कन्वर्ट किया, करेक्ट?
नो सर आई हैव 4 नेबल्स देयर नो 01 नेबल 1 is 1 नेबल 5 is 1 नेबल सर
One second. Let me clear once again. I'm getting confused. One second. You're talking about 0015, right?
yes sir
This is the first nibble. If you convert it into binary 0000, him.
Yes, sir.
If you convert 0 into binary 0000, done. If you will convert 1 into binary 0001,
0
okay, yes, 5, my mistake,
0011
011, correct. Okay, I was taking it as a 15. All right, good. Clear now?
Yes, sir.
Okay. So yes, this was the first rule. Any confusion in this?
No, sir. Okay.
No, sir.
Okay. Now let us come to the second rule. The second rule is we can remove the successive fields of 0 and we can indicate it as a double colon. If you want to make a note, you can write it like this. We can remove successive zeros and indicate it as double colon. Done? What does it mean? Take example. Suppose I have FE08 colon 9E04, then 0000 colon 0000 colon 0000 colon 12345 12345. Okay, now say 000 colon 0000 colon 0015. So if I have this value, okay, now let me change the color. If I want to shrink that address, if I want to shrink that, how can we write that? Sorry, FE08 colon 9E04. Now you can see this field, this field, this field. These three are in the sequence are successive 0, right? So we can indicate dot 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 dot. That's it. Now again here, as per the first rule, we can remove the leading 0. We can write this as E colon. Again we have 40 here. So in one address you cannot give double two times this double colon. Okay, so this can be indicated as only 0 colon and then 15. Okay, any confusion?
सर जब यहाँ पे 3 बार 0 आते 3 कॉलम नहीं आएंगे?
नहीं, 3 बार हो, 4 बार हो, 5 बार हो, 6 बार हो, that doesn't matter. If suppose I will have 0000 here as well, if I'll have 0000 here as well, and yes, if this could be the condition, then we can write this as a FE08 colon colon 15. That's it.
Okay.
Okay, all the successive fields of 0 can be eliminated and we can indicate as double colon. If the situation is like, suppose let me clear this. Okay, okay, if the condition is 3 successive zeros here and then 2 successive zeros here, okay, let me this, we will take the highest one. Okay, so we have 3 successive fields 0 here, so we will indicate double colon here, then E as an E, and then this could be 0 colon 0. Okay, done? Any confusion in this?
No, sir.
No?
Yes.
Okay, now let us come to the next point.
Sir, one doubt, sir. One doubt, sir.
Yes, please.
Uh, in case I will seeing first time in this one FE08 blue color, right?
Haha.
Blue color.
Okay, this one. Okay.
This one.
Hmm.
In double colon is there, na sir? That is how to find that, sir?
Okay, say, okay, let I understand your question. Say if I am
Yes,
having
sir.
an IPv6 address FE08 colon 1234 colon D colon 0. Okay, so how to expand that, right?
Yes,
How
sir.
to
How to
expand?
find that how which exit that in middle there and how to find?
Exactly. So this is the first FE08, FE08 colon 1234 1234. Now we have successive zero field here, but we are not aware like how many fields are there. Okay, let it be. We have D and 0 at the end. So we have colon D colon 0. So how many fields we have? 1, 2, 3, 4, right? I in IPv6 we have 8 hex set. I have the value of 4 hex sets. In between we have a successive 0. So we can say 0, 0, 0, 0. Simple. 1, 2, 3, 4, 5, 6, 7, 8. You can do this. If you want to expand it more, you can write like this: 0, 0, 0, 0, 0, 0, 0, 0, colon 0, 0, 0, 0, colon 0, 0, 0, 0, colon 0, 0, 0, D colon 0, 0, 0, 0. Okay,
Okay, fine.
done, Parmeshwar?
Yeah, done, sir. Done.
It's a very simple. No need to take any pressure. It's a very simple. Do not make it complicated. Okay, it's a very simple. Any confusion for anyone? Any confusion, guys? No.
Yes, I'm confused. Very,
Where?
very confused.
Where confusion?
From, um, from the beginning of the second one,
You're talking about this one, right?
from the beginning of the
FE08, this
second
one.
row. Yeah.
One second. Let me
Can you
make
hear
it
me, sir?
clear. Yes. Tell me. Hello.
Uh, I mean from the second row. From the second row. Yeah, can you hear me?
Yes, I can hear you. Tell me.
Okay, I said the second rule is confusing to me. I don't know if you can take it again if you don't mind.
Definitely, definitely. I will repeat it 10 times.
All right.
That's the confusion. So what is the confusion? First of all, what is the confusion? The second rule is we can remove the successive field of 0 and we can indicate it as double colon. Simple. Is there any confusion in this sentence? In this sentence? Any confusion in this? Guys? What's your name, brother? Godson, right?
Yes, God sake.
Yes.
Okay, I'm clear. I think I'm clear now. But what if,
Uh-huh.
sir? What if
Yes.
these zeros come after, like, let's say we have F808
Uh-huh.
semicolon
Uh-huh.
9. Is that
Ni-
E?
yes, 9E04.
9E04. Then the rest are zeros. What do we do then?
This all zeros,
Yes.
we have
Yes.
indicated this as double colon.
You mean
This
like after the second hextet, we would
after second
indicate
hex
double.
sets, yes, we have
Yes.
three successive field of zero, so we have indicate that as a double colon.
Okay. No, I
And
mean like after the second hextet,
uh-huh,
the remaining hextets are just zeros.
yes,
What do we do? Do we indicate like the two semicolons after the second hexes? That was we will have FE08,
uh-huh,
9E04, then
uh-huh.
two semicolon. Would that is that how it's going to be?
Exactly, that is what I'm telling you. All successive
Okay.
fields of zeros can be indicate as double colon.
Double column.
Yes,
Okay. Okay. I'm
that is
clear.
what
I'm
I
very clear.
that is why I explain you here. If I will have,
Okay.
let me take another example.
All right.
Say if I will have IPv6 address FE08 colon 0000 colon 0000 colon 0000 colon 0000 colon 0000 colon 123456 1234 colon 0001. Okay, which is IPv6 address. So this we can indicate this as a FE08. Then all successive zero fields can be indicated as double colon, and then in this we can write 1. That's it. FE08 colon colon 1. As simple as that, right?
Sir, I'm asking, what if the last hex text is just 0000?
Then
That's where
only
my question is coming from.
only FE08 colon colon. That's it.
Oh, exactly. Okay, okay,
If you
okay,
have
okay. I'm
zero
cleared.
this
I'm
one,
cleared. Yes.
FE08 then colon colon. No
Okay,
rocket
okay.
science.
All right.
Simple rules, simple
Thank you.
concept. Okay.
Yeah, thank you.
Now any question from anyone? Any question from anyone? No. Okay. Let me come here. Mm. Now, so in IPv4, we had learned about unicast, we have learned about broadcast, and we have learned about multicast, right? What does it mean? Unicast means one to one. If I'm saying and someone is listening, that is called one to one, unicast. If I am saying and all are listening, that is called broadcast. If I am saying and a group of people is listening, not all, it means multicast. Now here we have another term, anycast, one to nearest. Okay, here this is only in IPv4 and this is only in IPv6. Okay, any confusion in this? We do not have broadcast concept in IPv6. Okay, any confusion guys? Any confusion in this, in understanding this? No. All right, now we have, okay, let us say types of IPv6 addresses. How many types of IPv6 addresses are there? It's a very important, okay? Basically, we have 5 types of IPv6 address. How many? 5. So we have 5 types of IPv6 address basically, normally, okay? The first one is unspecified. What does it mean? Unspecified. Say, what does it mean? Unspecified means what? Just look at the term unspecified. What does it mean? If I say all
Yep.
the fields are 0. Okay. In IPv6
Okay.
address, all the nibbles are 0 in binary. Okay. In binary, all the fields are 0. If I talk about IPv6 hexadecimal, we can say colon colon slash 128. In IPv4, we were using CIDR value and subnet mask. Here, we are not using subnet mask, but we will notate that as a CIDR notation. Okay. So if I'm saying all the fields, all the nibbles, the value of all the nibbles are 0 slash 128 in IPv4, just correlate it. In IPv4 address, where we were saying 0.0.0.0 and subnet mask was 32. Okay, or any IP address subnet mask 32 means in IPv4 we had 32 bits, and if I'm saying 32 as a CIDR value, it is indicating what? A particular IP address, right? A particular host. Do you remember, like when we were creating loopback address in OSPF or in ACL? Remember what were we doing at that point of time, guys?
Yes, sir.
We were taking 1.1.1.1 and subnet mask was 255.255.255.255, right? So the question was arised at that point of time, so why we are taking this IP address? It means we are taking 32 bit, which means I am indicating only one particular host, not a network. So the same is here. If I'm saying 128 bit and indicating this all 0 as 128 means that is not specified, nothing is there. Okay, so that is called unspecified. Why we will use unspecified? Where exactly in IPv6 we will use unspecified IPv6 address? The use is for multicasting the DSCP request. Okay, multicasting the DSCP request. And one more thing is there. Okay, just point it out. In IPv6, DSCP is not required. Okay, we will learn further why it's not required. DSCP is not required in IPv6. Okay, so how will we get the IP address? Automatically through the link local. We will learn further. Once we'll come to the link local address, then we will learn about that, how we will get the automatic IP address. So in IPv6, DSCP is not required. Just make a point, note down, IPv6 eliminates NetPet and DSCP. Okay, but still if you want you can configure DSCP, but that is not required. So the first point is that. The second is, yes, unspecified IPv6 address is used for multicast the DSCP request. Okay, as I told you, DSCP is not required, but what does it mean? If DSCP is not required, why we will use the multicast DSCP request? I'm saying DSCP configuration is not required, but if someone is requesting for IP address, that is the DSCP request, right? So I'm saying DSCP configuration is not required, but DSCP request, whenever you will get the DSCP request to the router for the IP address, the router will the router will multicast and provide the IPv6 address. Okay, is it clear? Is it clear? Any confusion? You can write down here what is the use used for multicast DSCP request. Done? Any confusion, guys?
No, sir. No, sir. No, sir. No, sir.
Good. Now let us come to the second. The second would be loopback. Now in IPv4 address, just tell me honestly, okay, in IPv4 address, what was the loopback range?
127.00 dot zero dot
127
zero
dot x
dot
dot
zero
x dot x,
dot one.
whatever, like 1 to 7. If any IP is starting from 1 to 7, in
Yes,
any
yes,
octet,
yes,
whatever the
yes.
value would be, that is the loopback address,
Look
right?
back. Yes, yes, sir.
But honestly say, do we really require that much? If I'm saying this, how much IP address we are wasting? For loopback, we required only one IP address, right? For loopback, we just required one IP address, 127.0.0.1. But this entire range was the loopback range, correct? So if I'm talking about this, it is a class A IP address. Ideally, uh, practically this is the
Yes,
class A IP address. So if I'm
yes,
saying, if I have 127.0.0.0, if class A we have 8 bits by default, it means we have how many hosts in this network? 2 to the power 24 minus 2, right? 2 to the power 24 minus 2. I just required
uh,
one IP address for the loopback, rest all are getting wasted, which was the public IP address, but unnecessary that all IP addresses was wasted. But here the condition is something different. We have, this was the condition of IPv4 address. Now in IPv6, if I talk about loopback, we have, let me clear this. Okay. If I talk about binary, it would be 000, all 000, at the end it's 1. Okay. If I am indicating in IPv6 term, if I'm talking about, this would be 1/128, a single IP, all 0 at the end, 1 in binary. In IPv6 in hexadecimal format, if I talk about, all zeros at the end, the value is 1/128. That is the loopback address. That's it. Okay. No wastage of IP. It is defined in IPv6 only 0000 colon 0000 colon 0000 colon 0000 colon 0000 colon 12345 1234 colon 1234 colon 1231. If this is the IP address, this is the loopback. That's it. It's a defined. Okay. So no wastage of IP address. Done. Any confusion in this? What is the use? We all know that. What is the use of loopback? Just for testing and pinging itself, right?
yes. I have a question, sir.
Yes, please.
Okay, in IPv4,
Uh-huh.
there was a specific look back, like 127.000.0.0.1. So are you saying that in IPv6 there's no specific look back, but any IPv6 with one at the
In
as in at the last
IPv4,
hex text?
in IPv4, for loopback,
Yes, sir.
if you go to the theory part, this
Okay.
entire 127, not, we were using 127.0.0.1, but if you go to the theory part or check anywhere, you will get the loopback range is 127.x.x.x. Whatever is there in 3 octet, that is the loopback address.
Okay.
Let me show you.
All right, sir.
Here we go. IPv4 Mm, here, look here. Can you see that, guys? Look here.
Yes, yes, sir.
Okay, more than
Yes.
16 million addresses was there. 2 to the power 24 means more than 16 million, right?
Yes.
Look here. Okay, but we were using 127.0.0.1. Okay, rest all
Mm.
was wasted. But in IPv6 we have, it's identified, it's predefined that if we have all zeros and at the end it's one, that the single IP, if I am saying 128 bits, means I'm indicating the single IP, right? So that single IP would be the loopback address. That's it. Any confusion in this, guys?
Yeah. So I'm still confused, sir.
Yes, please
My
tell
my
me.
question my question is this: are you saying semicolon semicolon one is a general look back in IPv6?
Correct.
All right. Okay. All right.
Okay. So what is the confusion? I'm not getting your point. What is the confusion?
I was comparing IPv6 to the 4, where we have just 127 as a whole loop back address. I
Yes.
was not really getting the part. So in IPv6,
Huh.
it's not the same, right, sir?
Why? Okay. Now, why we required IPv6? Just because IPv4 is getting shortage, right?
Yes,
Why
yes, sir.
it's
Yes,
getting
sir.
shortage? Because there was a, like very loopholes, and lots of IP was getting wasted, and population and the connectivity is getting increased and increased. That is why now IPv4 is getting shortage, and we required IPv6 address. So IPv6 comes into picture just to save the IP address. But fortunately we have lots of IP address in IPv6 address. If a single device will use a public address in the entire world, then also that IP is not going to shortage. How many IP addresses you have in IPv6 public IP address? If you will calculate, you can say 2 to the power 128. You can say that
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
in IP, like you say v4, just like that. You want to convert it, you can say 2 to the power 128 addresses are there in IPv6 address. If you convert it, it will be huge. Okay, so that is the reason. So earlier in IPv4 we were wasting a lot of IP addresses for loopback range, which was not required. Okay, that is solved here in IPv6, and we are using only one IP address for the loopback address. Done? Any confusion? No?
No, sir.
Great. Now let us come to the third types of IPv6 address. What are the third types of IPv6 address? Third is global. Global. Just like in IPv4 we had public IP address, you can compare global with public. Public IP address in IPv4. What was public IP address in v4? What are the benefits and what are the features of public IP address which was not there in private IP address? Say.
I think 192.168, right?
Sorry.
Um, you're talking about public. Sorry, no, that is
Yes, in
private, sir. Sorry.
IPv4 address. Yes, Pawan, good afternoon. In IPv4 address we had two concepts. One is private and one is public. Okay, we know the range of private IP address in IPv4, public IP address in IPv4. What was the difference? Why we use and where we use private and where we use public IP address? Guys.
Private is VLAN local area network is private is taken for IPv4. Public
Mhm.
is internet or server side is taken public IPv4, sir.
Okay.
From my own area, I think private is used maybe in a sector, maybe say an office. You
Mhm.
don't with so many computers you use private, but once you have to do with internet connection,
Mhm.
you use public. But if you're not really connected to internet, just communication across offices, you can use private.
Okay. The main is still the main point is missing. Whatever you guys are saying, that is correct, but still the main points is missing. Difference between private and public IP address.
Private is own, sir.
Private is,
Own.
sorry,
Own
not
net.
getting. Private is one
Private
network
is own network area.
and public is
Global, sir. I mean internet side, server side. Receiving.
still the basic main difference is missing. What are the basic main difference between private and public? Okay, I'm just giving you hints. Why we use net? We use netting? What are the requirements of that?
To get
You
the
mean
Uh-huh.
इंटरनेट इंटरनेट के लिए हम नेट का यूज करते हैं.
I'm talking about network address translation, netting.
NAT is used to configure a private
Network network address
address
translation.
translator. Yes, is to map a public private as address to as many private IP
Guys,
address.
guys, 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 guys. Okay, I think still this is not clear to you guys. The simple basic concept was private address cannot be routed on an internet. That is why we required netting to translate the private address into a public address so that we can communicate with the internet. So the difference was, the major difference was, private cannot be routed on the internet, public can be routed on the internet, right? Am I right?
Understood, sir. Understood, sir.
Everyone, this was the basic main difference between private IP address and public IP address in IPv4. Private cannot be routed to the internet. That is why we required netting to translate it into the public IP address. Correct? Yes. So global address is a public IP addresses in IP4. You can compare the global just like a public IP addresses. Now, how to identify the global IPv6 address? Okay, so there is, if I talk about in binary, it would be uh, first three. Okay, if I talk about binary, 1 2 3, then whatever is there, that doesn't matter. Means first three octet, or sorry, first three, you can say bits. First three bits would be 001. All time first three bits would be 001. What does it mean? I'm not talking about hexstat, I'm talking about binary. If I'm saying the first three bit is uh, 001, what does it mean? It always start from 2, correct? 0 0 1 and then 0. If I have 0, the in the first nibble the value would be 2, right? Or I'm talking about first three would be 0 0 1. It can be 1 as well. So 2 or 1, 3. 2 or 3. If the first nibble of any IPv6 address, you are getting it as 2, you can understand that that is a global IPv6 address. Okay. Now the example is, okay, in hexadecimal, if I talk about hexadecimal, this would be 2 and then 000. After that, whatever is there, that doesn't matter. I'm just comparing the 3 bits. Okay. I'm just comparing the 3 bits. Okay. So the 3 bits is this, right? Any confusion in this? Many confusion. I hope so. Guys, confusion, right?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. Let me break it. If I'm talking about first 3 bit would be 001. 001. Rest all whatever is there, that doesn't matter. If any IP address with first 3 bit as 001, okay, would be the global IPv6 address. Now you can put, we have 128 bits here, okay, long 128 bits. I'm talking about binary. Okay, this is in a binary. Now 001 is fixed. 001, I fixed this 001. After that, it could be 000000000, anything 000. If this is the condition, 0000010, the first nibble, 1 2 3 4, the second nibble, 1 2 3 4, third nibble, 0000, fourth nibble, then separated by dotted, again 0000, all 0. So what I'm doing, if I'm converting into binary, we have 0000 here. If I'm converting into the hexadecimal, it would be 2 0 0 0 colon. After that, whatever value is there, that doesn't matter. Here also, whatever the value is, that doesn't matter. The first one, the first nibble, if I'm talking about this 4 bit, first nibble means what? The first nibble means the first
First number, sir.
number
The first
of the hex
character.
state.
First character. Yes, sir.
First character of the hex state, right? So if I
Yes,
have
sir.
001, the character would be 2, the value would be 2. If I have 001 1, the value would be 3. So if the first character or first nibble is indicating 2 or 3, that is the global IP address. Okay, the range, you can say, if I'm saying this, what does it mean? The range of this would be 2000 to 3FFF, if I'm not wrong. Am I clear? This is the range. Just think logically. Okay, I know it's a tricky. I can understand. Okay, let me clear once again.
Clear. It's clear.
We have a few members, like they are very shy. They will join the entire session, but they will not say a single word. I know that. Right now you can see here, like 16 people are there, but only 2 or 3 are communicating. Rest 14 are just watching the session silently. Even they will have the doubts, but they will not ask anything. They are that much of shy. Okay, so for them I have to repeat again and again, because I know that they will not ask. If they will have the doubts, they will not ask. Okay, so I know there is a confusion, so I'm just clearing it once again. From where this value comes? Who is this? Free. Okay. All right. So now, from where this value comes? 20002355. This is the range of global IPv6 address. From there, where this value comes? I'm talking about global IPv6 address. The indication of the global IPv6 address is the first 3 bit would be 001. The first 3 bit would be 001. If I have 128 bit long number, the first 3 bit is 001. Okay, I'm converting into the nibble. 1 4. This is the nibble. Okay, I'm talking about nibble. 4 4 4 4 colon 4 4 4 4 colon. This is including 16 bits in every hex set. 4 4 4 4 4 4 4 4. Okay, this is the nibble. 4 bits. I'm indicating the 4 bits as one hex state. So if I have 4 bits here, the value is predefined as 0 0 1 and 0. So if this value would be 0 0 1 0, minimum it is 2, right? The first, rest all I can say it's 0. Either this, or if I cannot change this one, I cannot change this one, right? I can change from here to here. If I'm like taking it 0, the value would be 2 0 0 0. If I'm taking all as 1, okay, it would be 3. 2 plus 1 3 in first nibble, and rest all would be 15 15 15 15, means F F F, right? Right,
Yes, sir.
guys?
Yes, sir. Yes, sir. Yes, sir.
I think it's crystal clear now.
Yes, sir.
So in first octet, in first hex state, if the value is from 2000 to 3FFF, that would be the range of global public IPv6 address. Any confusion in this, guys?
No, sir. No, sir. What you're saying is if an IPv6 address falls between 2000, its first hectare falls between 2000 to
Mhm.
3FFF. It's a global
Global
IPv6 address.
IPv6 address. Correct.
It's clear, sir.
Guys, any confusion to anyone? Boris, clear, okay. Anyone? Godson, Haim, Isenio, Messi, anyone? Yes?
Clear, sir.
Yes, Haim. Clear?
Yes.
Anyone has any confusion? Parmeshwar, Stephen, Viral, Shaurav, anyone, any confusion?
Not clear as well.
Great. So this was the third thing. And as I already explained you, global public address, what is the use? It is just like the public address in IPv4 address. Done, guys? Okay, now this is the third type of. Now let us come to the fourth type. What is the fourth type?
Sir, please don't be
Yes.
annoyed. But I was thinking the IPv6 address is so large. So
Uh-huh.
why was it? Why is it just from 2000 to 3FFF? It's just the only global. I was thinking it's just that means private is so much.
What does it mean?
Private
What
is
does
so
it mean?
much.
Just try to understand. What does it mean?
Okay. It means that
No.
IPv6 addresses that falls between that range are the only IPv6 that
No.
can be used.
You are wrong. You are wrong. Let me explain. Very good question.
All right, sir.
Trust me, it's a very good question, and it's a very informative question would be for everyone. Now, if I'm talking about 200023FFF, what does it mean? Okay, let me show you how many IPs you are getting from this value. Okay, I am talking about 1 second. 2000 colon anything 2 3FFF colon anything. If I am fixing this hex state as a global IPv6 address, only the first hex state, means we have 128-bit long address in which I'm just fixing the 16-bit. Rest 112 is still flexible over here, right? Okay, so how many IP addresses you are getting? 2 to the power 112 from each single IP address. If I'm talking 2000 from this particular network, if I'm taking it as a network 2000, from this particular value we will get 2 to the power 112 IP addresses. Let me give you the calculation how much IP address can be get from that particular single value. Okay, 1 second. Mm, scientific. Okay, 2 to the power 112. Will you use this much IP addresses in one network, in a single network? Will you use that?
No, no.
It's impossible.
Yes, sir.
So it's a huge. You are thinking like 2000 to 3FFF. This is not this. This is actually
Yes.
this.
In 2000.
Okay.
Like that, the figure you showed us is just for 200.
Exactly.
2000. Imagine
Exactly.
2001.
1
2002.
2002
Yes. Okay. Okay. Wow.
2001, then 2002. It will go
02.
200F. Then again
Yes.
2010,
001. Yes.
2011,
Yes. Yes.
2012, again 201F,
To
then
F.
202. It will go like
Yes.
that.
Okay. Okay.
Very good question it was. Okay. Now it is clear now. Is it clear now?
Yes, clear, sir.
Okay. Now let us come to the next point. Any confusion to anyone, guys? This is the future. Trust me, take it very seriously. This is the future. IPv4 address is, you know, it's done. Okay. Now the future is IPv6. So very interesting. Just learn it very carefully. Okay. Now the fourth one is multicast. What was the first one? Unspecified. Then we had learned about loopback. The third was global IPv6 address. Now the fourth one is multicast. What do you mean by multicast? We know multicast means one to many. Okay. Now,
Yeah, 1 2 minutes, sir.
yes. So if I talk about multicast IPv6 address, how will we identify? If I talk about binary, it would be 1111 I'm talking about binary, not hexstat. Okay. I'm talking about binary. This is the first nibble. This is the second nibble. Okay. And whatever is there, uh, first 8 bits. This is the fix, first 8 bit. If you are getting, if I'm talking about hex stats or IPv6, F, then 00, whatever is 8. If I'm talking about this would be the multicast IPv6 address. If any IPv6 address starting with FF, it means it's a multicast address. Okay, done? Any confusion? Now, what is the use of multicast address? What is the use? In IPv6, what is the use of multicast address? So, as I told you that DSCP is not required in IPv6. Okay. Here comes why, what is the reason? Multicast. Whenever any device will connect in the network, whether it is laptop, desktop, or any device, whether any device will connect into the network, they will automatically join a multicast group. Even you will give one IP address, one IPv6 address on the router, but if you will check, you will get multiple IPv6 address, in which automatically it will join a multi uh, cast group. Okay, the router will be automatically joined to the multicast group. It will get automatically a linked local IP addresses. Okay, so multicast is a IP address. Whenever a new device will join into network, that will automatically join into the multicast group, and it depends what kind of device that are and where exactly it is connected. Okay, that depends on that. Just try to understand. If this is a router, it's a little bit tricky. Okay, just try to understand. If this is a router, okay, now I am connecting multiple devices here. I have given a single IPv6 address over here. Okay, if you will go and check, you will get multiple IPv6 address. Okay, one would be the global IPv6 address which you are providing manually. Apart from that, you will get link local, multicast group. For different kinds of devices, there would be a different multicast group. Okay, so uh, once we will come to the configuration part, then you will get the deep information about this multicast IPv6 addressing functionalities, how it's working. Okay, so as of now, just try to understand any IP address, IPv6 address starting with FF. Okay, first 8 bits is 11111111, then it would be a multicast IPv6 address. Okay, the use is whenever any device in your network will join the network, it will automatically connect to a particular multicast group. From that multicast group, it will get the IP address automatically. Okay, how? I will show you. Now, this is the fourth kind of IPv6 address, multicast IPv6 address. Any confusion as of now from here? Any confusion?
No, sir.
No. The fifth one is link local.
Sir, sorry for cutting
Yes,
you short.
yes, please.
So you're saying the multicast in IPv6 is functioning like DHCP in IPv4.
I'm not saying DSCP in IPv4. I'm saying that you will not need to configure the DSCP in IPv6 whenever you are using the IPv6 configuration in the network. DSCP configuration is not required.
No,
Just
no,
because
sir.
of
What I'm saying,
IPv6, yes, just because of multicast, it will provide you the IP address
automatically.
automatically. Yes.
Thank you very much. Okay.
Okay. Now, uh, okay. The fifth one is link local. Okay.
Sir,
Yes.
hello. Yeah, so that means that there is no configuration, manual configuration in IPv6, correct?
Manual configuration means what? Manual configuration of DSCP is not required, but still people are doing
Yeah,
that, which is not required. Okay.
yeah, correct. I understand.
Let me
So
show you.
just
Uh, 1 second. Yes. Just carry on your question while I'm
yeah, so
launching
in
this.
IP4 we are doing manual IP addresses. So in IPv6 it's not possible. It's automatically only.
No, I'm not saying only. Whether I say only,
No.
do not mix up two things. You can give the IPv6 address manually to devices. I'm
Okay.
comparing between DSCP and IPv6 means if you don't want to put the IPv6 address on a device manually, you can get the IPv6 address automatically without configuring the DSCP in the network. Okay, so let me launch this one.
And also, I mean, CCNA packet tracer is not opening the latest version after this login.
What is happening?
It's showing your organization is not connected.
Have you tried to uninstall and reinstall?
No, I don't. I will try again.
Yes. What happened? Okay. Look here. In IP configuration, you are getting only two options, static or DHCP, right? Right?
Yes,
In IPv6, you are getting three options, static, auto configuration, and DHCP. Then how this auto configuration works, you can see here, link local address, which we are going to discuss now here, link local. Okay. So this is the, like you can say thing, okay, which will be help to give the unique IPv6 address throughout the world. We know that. What is MAC address? What is MAC address, guys?
it's a
What is,
unique hardware address.
can a MAC address be the same of two devices?
No.
No,
Huh?
no,
MAC address is a 48-bit number, which is uniquely identification number of a device in the entire world, right? It's born by the time of manufacturing, and it's a unique for a device in the entire world for any particular device, right? Am I right?
right.
So if the MAC address is unique, if I am merging, if I am mixing up a MAC address with the IPv6 address, okay, here is a technology, here is a concept, which IP address is taking the MAC address help in generating the IPv6 address. So obviously that would be the unique in the entire world, right? That is why each and every IP address is a global IP address. You can give a single PC IP address that would be the global IP address just because of the MAC address. Okay, link local IDs. So how it's possible? Let us come into that. Now, we were on this. What is link local? Okay, the first thing, just for theoretical knowledge, if I talk about binary 1111 first nibble, 1110 second nibble, uh, 10 in the third nibble. I'm talking about first 10 bit, rest whatever doesn't matter. First 10 bits. So what is the value? First 10 bit is FE8, right? So any IP addresses, if I talking about hex here or IPv6, it is FE8. Then rest are whatever, that doesn't matter. So first 10 bit is fixed, FE8. Okay. So first 10 bit is fixed. Any IP address starting with FE8, okay, would be link local. Okay. If I'm saying FE8, am I right? No, I'm not right, because this nibble and this nibble is fixed for 4 bit, but this is not fixed for 4 bit. It could be 10 here, right? Or it could be 9 here, right? Oh, sorry, binary cannot be 9. So 1 it could be 1 here. 1 second. Yes, 1 Can be here. So if I'm saying FE, any IP address starting with FE in the third, it can be 8 or 8 or 2, A or B. Okay, so FE8 or A or B. You can say FE8 or FE A or FE B. This would be the link local. Am I clear? Am I clear, guys?
Yes.
Now,
No, sir. No, sir.
okay, what is the confusion?
Um, are you? Is it particularly 8A and B, or from above 8
No,
to
if I'm
15?
talking about, okay, if I'm taking this nibble, okay, this nibble,
All right.
the first two is fixed, 1 and 0. This is fixed. This is the binary.
Okay.
Now, if I am taking this, the value would be 8.
8. Okay.
If I'm taking this, the value would be 8 or 2, 10 means A.
A.
If I'm taking this, the value would be
Okay, sir.
B.
All right. I'm cleared, sir.
Clear now? This one
Yes,
is
sir.
fixed. And in this, it can be 0 or 1. So either it can be 8 or A or B. FE8, FEA, FEB. So that could be the link local address. All right. Now, what is the use of link local IPv6 address? Let me clear this. In the simple term, we can say link local IPv6 address is responsible, or you can say link local IPv6 uh, address. Every IPv6 configured devices would have an address to be communicate in the network even nothing is going on in the network. If nothing is happening in the network, still they will be able to communicate between each other. Link local IPv6 address is the address which do that. Okay, you have provided global IP addresses manually or whatever to the every devices just for your own networking. Once you will configure, as I clear here, that once you will configure any IPv6 address, it will automatically generate the link local and multicast group and other IPv6. You will get multiple IPv6 addresses on that particular devices automatically. What does it mean? So link local IP address, you can say like every IPv6 devices. Okay, if you want, you can make a note. It is in a simple way in the definition. Every IPv6 devices would have an address to be able to communicate in a network even if nothing is happening in the network. Okay, as simple as that.
सर कम्युनिकेट मतलब क्या उसके सारे रिसोर्सेज एक्सेस कर सकता है?
नहीं, आपस में बात करने के लिए, जस्ट आपस में कम्युनिकेशन. मल्टीकास्ट मतलब क्या? एक मल्टीकास्ट ग्रुप में जितने भी डिवाइसेस कनेक्टेड हैं, okay, they will, if you are not doing anything in the network, they will keep communicating between each other, not sharing the resources, but they will be checking the connectivity. That's it.
तो सर आईपी की तो जरूरत पड़ेगी इसमें?
बिल्कुल.
ये बिना आईपी के भी हो जाएगा, लिंक लोकल एड्रेस से भी हो जाएगा.
लिंक लोकल एड्रेस से भी हो जाएगा, but just for your identification, if you are creating a network, you will use a global IPv6 address, right? So for the communication between the external network, you will require that IP address, global IP addresses. Link local IP addresses is just for the communication between that multicast group. ओके, जब हम लोग प्रैक्टिकल में आएंगे तब हमको इसके डिटेल्स में समझ में आएगा कि अच्छा ये क्या कर पा रहा है, ये क्या हो पा रहा है, ठीक है, व्हाट एग्जैक्टली इज हैपनिंग। ओके,
सर एक और पूछना था सर, जो आपने ये बताया कि जो फिजिकल एड्रेस होता है
हाँ हाँ,
वो आईपी में एक्सेस करते हैं करके बोला था, ये समझ नहीं आया मुझे।
आईपी में एक्सेस नहीं करता है, IPv6 जनरेट होता है बाय द हेल्प ऑफ दैट मैक एड्रेस। ऑटोमेटिकली जनरेट कैसे होता है? ऑटो कॉन्फ़िगरेशन, हाउ ऑटो कॉन्फ़िगरेशन, आई वाज शोइंग यू ऑटो कॉन्फ़िगरेशन IPv6 address, how it will get the auto configuration. So in that auto configuration I will show you how it works. This is just the next topic after this link local. If you are clear, if everyone is clear, the next topic is how link local address is getting generated. Okay, so is it done, the theory part, like link local? Yes.
So sir, you're saying because if I can remember vividly in the router when configuring sorry, I'm going towards this part, but I'm trying to get to a point, sir.
Uh-huh. Yes, tell me. No.
When you're trying to configure an IP router IP configuration,
Mm-hmm.
you something like arrow IP, EIGRLP, I know they keep communication among themselves. That's what this link local address is, right? It keeps
Exactly.
communication amongst devices connected in a network, something like that.
Once will come, like each and every single port of the router as well will get the link local IP address.
Okay, but that's what it is like. That's what this link
First
local
of all,
address can.
exactly. First
Okay,
of all, let me come.
all right, sir.
Every single device will get the link local IP address, or every like interface will get the link local IP addresses of the router as well. Let me come to the how it is getting generated. Then you will understand where and how it is getting generated. Everywhere, wherever the MAC address is, you will get the link local IP addresses.
सर तब भी
Okay, sir. Okay, sir.
और 128 वाला ये तो फॉलो ही नहीं होगा
क्या फॉलो नहीं होगा मतलब?
सर, जो इसमें 2 की पावर 128 इसमें आईपी एड्रेस होंगे।
हाँ हाँ,
हाँ, तो ये तो फॉलो नहीं होगा बाय द वे। अगर क्योंकि ये बहुत ज्यादा आईपी एड्रेस होती है, अगर
हाँ,
भाई हम इसको भी हम रीच कर जाएं और उससे मतलब फिर एक्स्ट्रा अगर कोई डिवाइस आ जाती है, उसका मैक एड्रेस तो कोई श्योरली आईपी कोई दूसरा ही होगा।
बिल्कुल, मैक एड्रेस चेंज होगा तो लिंक लोकल एड्रेस चेंज हो जाएगा।
वो 128 से भी एक्सीड कर जाएगा फिर तो ये। फिर तो इन्फिनिटी हो गया ये।
इन्फिनिटी, भाई तो बोल रहा हूँ 2 टू द पावर 128 करो तो पहले एक बार 2 टू द पावर 32 16 मिलियंस होते थे, राइट? 16 billions. 2 to the power 32 means 16 billions. If you will multiply this 2 to the power 33, what would be 32 billion? 2 to the power 34, 128 billion. So you can imagine 2 to the power 128 how much it would be.
इन्फिनिटी।
Okay, so don't go into that. Okay, just learn the simple concept. कुछ कुछ यहाँ पर स्पेसिफाइड है, समथिंग इज स्पेसिफाइड लाइक how you can identify the loop back, how to identify the global, how to identify the multicast, how to identify the link local. So these are predefined. Okay, so just identify that only. Don't go into that like how will I get that IP address, how will I get that much IP address. It's a use. Okay, so no need to go into that. Okay, so now link local is done. How link local ID is getting generated automatically. Now this is the next point. So if you are clear, if you guys are clear the basics of link local, what is this? The first thing is, if you convert into binary, the link local would be 1111. You can say here 1111 1110 10. Okay, in IPv6 term you can say any IP address starting with FE8 or FEA or FEB, that would be the link local IP addresses. This is done. Now how link local, this is the worst part of the IP address. Okay, it's very important to understand this thing because you will face this link local everywhere and it's a very important thing as well. So This is done till now, the theory part. Link local, what is link local? Now the next topic is how link local addresses gets auto generated. How uh, how link local IPv6 address auto generated. This is the topic. Now the rules is uh, the rule is EUI64. This is the rule. What does it mean? What does it mean? Extended unique identifier. EUI stands for extended unique identifier. Now, if I break this term, extended unique identifier, what does it mean? It's a very simple, right? The first thing in EUI, you can see here, like it's a 64 bits. EUI is 64 bits. Okay, let us say we have a 64 bits number. The rule is I will use a 64 bits number. Just try to understand. Rules EUI says I will use a 64 bits number. Now, the question is which 64 bit number we are going to use to extend a number, extend the IP address uniquely. Here comes MAC address, because we know MAC address is also a uniquely identifier number of a device, correct? So, but the challenge is that the MAC address is of 48 bits, correct? But we have to use 64 bit. The first 64 bit, okay, normally, just for your information, normally what is happening in this world, ISP is providing 48 bit. Just for your information, ISP is providing a IPv6 address with 48 bit. Okay, means it would be like something 2001 colon DB8 colon F312 colon this is okay 48. This 2001 here one, okay, this IP address had been provided by the IPv6, oh sorry, ISP. Now if you check here, this first hex state, second hex state, third hex state, this is fixed. You cannot make changes in this hex state. Once we will come to the subnetting part tomorrow. Now at that point of time we will understand it in a clear format. So every bit, every hex state has 16 bit. If I'm talking about 48 bit, means these three hex state are fixed, correct? Now people are doing what? People are doing it as 64, means these three octet are fixed, means 2001 colon DB8 colon FE12 colon the fourth, okay, say X 64. If I'm saying this, if I am converting 48 into 64, what does it mean? Just compare it with IPv4 address. That is why at the very beginning of the class I said it is similar to IPv4. If your IPv4 concept is clear, it is very much clear. Okay, it's very simple. If says I'm taking the example of class A, the by default subnet mask was 8-bit. If I was taking it as 16-bit, how much networks I was getting there? Number of network would be 2 to the power 8, right? Right, guys?
Yes, sir.
Yes, yes,
Yes,
yes.
sir. Yes, sir.
If I am converting 8 bits and I am modifying with 16-bit it, the network, total number of network, I will get it 2 to the power 8, right? Means 256. Done? No confusion in this.
Yeah.
The same thing
Yes.
is happening here. If I am customizing 48-bit with 64-bit, means the entire 16-bit here, I'm modifying that, customizing that for the network. How much network I'm getting? 2 to the power 16. Correct? I'm taking 16-bit as a network, so I can modify, I can get 2 to the power 16 networks. I can create 2 to the power 16 networks from there, means 65,536 network I can create from one this hex states.
How? How, sir?
It's simple. If this is fixed, okay, we have 16-bit here. I'm taking the first network as 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, okay. Then after whatever
Oh,
the value would be, this is the one network. Then
yes, yes.
2, that is the second network. 3, that would be the third network. Fourth, till F I will go and I will get 15 network, right? Just after
Yes,
that
sir.
I will convert it as 1 0, then 1 1, 1 2, 1 3, 1 4, 1 F, again 2 0, 2 1. Once I will get F F, then I will get 1 0 0, right?
Accurate, accurate, sir.
Once I will get F F F, then I will get 1 0 0 0, right?
Yes, sir.
So we have 16 fields here, means we will get 65,536 network
Network.
from one hex state. It's a huge, right?
Yes, sir.
Not only this, brother. Let me show you the magic. If I'm saying you are getting 65,536 network, it is not the done. This is just the beginning. Okay. Now think about, okay, now you will get the power of IPv6. I told you that 2001 db8.fe12, I can get 65,536 network. Let us take, I'm just taking the first network, everything 0, I'm just taking 1 here. The last bit is 1, okay? 0001, 0001, okay? Slash 64. What does it mean? What does it mean? From this network, how many hosts can we get? The rest 64 bit. The rest 2 to the power 64 bit. This is the, from this network, this much host you can get. Can you imagine? And this all are the public IP address. This is the public, right? Global.
Yes, 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 yes. 200. Yes, sir. Yes, sir. Yes. It's the global IPv6 address.
So what is the 2 to the power 64? Let us check.
64.
2 to the power 64. Just count. I can't count it. You just count it. Okay. This much IP address you will get from one network, and this kind of network you can get 65,536 network.
Networks containing this amount of individual hosts in each network.
Yes.
Wow.
Okay. So this is the power of IPv6. Any confusion in this?
अरे ऐसे में जो है आईपी का वेस्टेज नहीं होगा?
कहाँ से वेस्टेज हो रहा है?
सर सपोज दैट जो 60,000 जो जितने इसमें नेटवर्क बन रहे थे,
हाँ हाँ,
तो दैट उतने लोगों ने, ऑर्गेनाइजेशन ने अपने अपना अपना जो है नेटवर्क ले लिया, वो शेयर नहीं करना चाहते किसी दूसरे के साथ।
कैसे ले लिया? कहाँ से शेयर नहीं करना चाहते हैं? कैसे ले लिया भाई? यहाँ पर तो every single piece is getting a uniquely public IP address. You are not going to divide the network. Okay, say okay, for example, okay, पहले हम लोग ये कंप्लीट कर लेते हैं, लिंक लोकल का जो कॉन्सेप्ट है वो कंप्लीट कर लेते हैं, देन वी विल कम इनटू लाइक हाउ वी आर गेटिंग दैट एड्रेसेस. ओके, सो यहाँ पर तो क्या था कि देखो 48 बिट दिया गया है. अगर यहाँ पर ओके, जस्ट टेकिंग योर कॉन्सेप्ट, अगर वेस्टेज की भी जो बात है फ्रॉम वन, ये तो हो गया कि ये ISP had provided this network, okay, /48, this network, okay. Just think like that. We have 64 plus 16, 80 bits for ISP. They had complete 112 bits to modify. Okay, just for global address, they have 112 bits to modify. If you convert 2 to the power 112, you will get that much of network which ISP can provide. This is only when you are calculating this as a network 2001. But I told you in the first hex state that this can be from 2001 to 3FFF. Can you imagine?
काफी नेटवर्क है.
Just imagine like how much networks we have in IPv6 address.
Yes, sir. 2 to the power
Just
1
forget about the like host. Okay, forget about the host. अगर एक एक पीसी को एक एक नेटवर्क भी दे देना भाई तो भी खत्म नहीं होगा. ठीक है. So this is the power of IPv6. Got it? All right, now let us come to the topic. We were here, right? So what is extended unique identifier? This is a rule through which link local, how to get the auto generated link local IPv6 address through EUI64 rules or method, you can say. Okay, but the thing is that EUI means extended unique identifier will use your system MAC address to generate the IPv6 link local address. But the challenge is that we have 48 bits MAC address, right? Right? Now, if we have 48 bits, the first 64, as I told you that people are doing what? They're taking 64 as a network. Rest 64 would be the EUI. Okay, rest 64 would be the EUI. But if I consider MAC as a EUI, we already have 48 bits, from where we will come 16 more bits. So this is the method, this is the process how we will convert, how we will do the changes and generate the extended unique identifier link local IPv6 address. Now we have basically three rules to convert a MAC address into EUI64. Okay, the first rule is, the first process is, come on, the first one is, we will divide, we will take the MAC address and we will split into two part. Let us take the example of this PC. Here you are getting the link local address. Done. Okay, we will check it later. Now first of all, check the MAC address of this PC. What is the MAC address? Here's the physical address. Okay, I'm taking the example of this PC so that you can understand. So we have 00060 colon 472B 472B colon 129E 129E. Okay, so this is the MAC address. First of all, we will split it into two part. So we have 48-bit. This is one nibble. Okay, 16 value means 16 into 4, 48. Sorry, 16 into 3. Okay, now 00647. Okay, I have splitted from here and two parts. Okay, so 006047 is a one part, 2B129E is the second part. Any confusion? No? No? The second point is, okay, first one is split. Split MAC into two parts. This first. The second, insert FFFE. Okay, insert FFFE in between. ठीक है, 00604 FFFE to B129E. Done? Done? Any confusion in the second? No. The third, we invert the first 7th bit. Sorry, not the first 7th, only the 7th bit. We will invert the 7th bit of the interface ID. Now, what does it mean? If I talk about the 7th bit, I'm talking about 7th bit, not the nibble. Make sure I'm talking about 7th bit. Each nibble having 4 bit, right? 4 bit means if I convert 0 into binary 0000, this 0 0000, 1 2 3 4 5 6 7, this value, if it is 0, you have to invert it as 1. If it is 1, you have to convert it as a 0. Okay, so you have to invert the value of 7th bit of the interface ID. Now if I invert it, what would be the value? This 0 will become 0. This 0 will become 0010, means 2, and then 60, rest all would be the same, colon 47FF colon FE to B colon 129E 129E. That's it. So this would be the link local address. Let us check if it's same or different. Let's look here. FE80 link local. Just forget about this. Just look from here. The last 16. 260. We are eliminating this just to shorten. 260 colon 47FF FE2B 129E. Exactly this, right? Guys?
Yes, sir.
Any confusion in this? How to generate the link local address?
So that we need to insert in between, or we can use starting or ending, sir?
No, this is the rule. You have to insert. We have to divide first.
In between, after how? In between, we have to use after 8-bit value, right, sir?
If you have divided a MAC address, it's a 48. If you are
Correct.
dividing like 48 bit, it will be 24 bit, 24 bit. If you talk
24.
about nibbles, how many nibbles are there? 1, 2, 3,
1,
4, 5, 6, 7, 8, 9, 10, 11, 12. 12 nibbles. So you will
okay.
divide into 6 and 6 nibbles. Okay.
Okay.
I'm confused with row three.
Okay.
Row three. I did not really get that part, sir. Thank you.
I have hell lot of PC here. Let us take any example. Okay. Now let us come to this PC. Okay. I'm taking the example of. Okay. First of all, just go here and check the ipconfig/all. So the MAC address of this PC is this, right?
00B.
Okay. Now let us take second example. I don't think I need to like explain or teach you guys subnetting because it's almost done today. You guys understand how to convert that. But if your IPv4 concept is clear, it is nothing. Like IPv6 subnetting is nothing. Okay. More or less ideas I already have given to you today only of the IPv6 subnetting, how to do that. Now, here we have 000B, fine. 000B, BE33 colon, BE33 colon, 3352. Okay, done, guys. Now, the first rule was we have to split this into two 0
Into
0
00B, BE,
BE. This is the first part. The second part is
and second
5
3
2. Oh, sorry.
so 3
Yes, 3352, right?
yes
333352. Done. This is the first rule. Done. The second rule, we have to insert FFFE.
in between
1 2 3 B E F F F E, again 333352. No confusion till here. Done.
no sir.
Yes, sir.
The third rule is invert the value of 7th bit. Now, if I'm talking about this, what does it mean? This is in hexadecimal format. Means every single character having 4 bits,
4
one nibble, 4 bits, right?
yes
So you have to invert the 7th bit, not the
7
nibble. So if I talk about this, this has 0000 4 bits.
0 colon
This will have 0000.
10
Now, what is the 7th bit? 1, 2, 3, 4, 5, 6, 7, 8. This one is the 7th bit. The
10
value is 0. It will be
1
inverted as 1, right? Now,
yes
if you will invert it 1, again, if you will convert it to the hexadecimal, binary to hexadecimal, let me convert it to 1. Okay. Now, I'm converting it to the hexadecimal once again. So, 0 means 0. 0010 means 2. The
2
decimal format is 2. The
2
hexadecimal would be the 2 as well, right? Then 0 and B, rest all would be the same. Then colon BEFF colon BEFF. Okay. Now BE33, sorry, FE33 FE33 colon 3352. Okay. Let us check. Physical data. Look here. Leave this one. 20B 020B leading 0 eliminated. 20B BEFF FE33 3352. Done.
Yes, sir. Accurate.
Clear now?
Clear, sir.
Anyone having any confusion, guys?
No, sir.
Okay, so this is also done. Now, I am just giving you guys, just take your pen and paper. I am giving you one MAC address, just convert and tell me the link local. IP config slash. Okay, take this MAC address and convert it into the link local. It's 6:26 p.m. You guys have 4 minutes. 6:30. Come on. Those who will complete, just leave your answer in the comment. I'm just opening the comment box, chat box over here. This is the MAC address. Okay, Stephen was there, but his voice was not coming and he gave the right answer. Public IP was routable, is routable, right? I want all 13 people's answer. Oh my God. Okay. Hey, do not cheat, okay?
Sir, I sent you, sir.
The help of cheating or you
No,
didn't?
sir. No, sir.
Okay. Come on, guys, everyone. Apart from Pawan, everyone, guys. Philip, Boris, Chandrasekhar, Salzubon, okay. Godson, Galaxy Note 8, Hem, Parmeshwar, Stephen, Suresh. Guys, come on. Ping your answer immediately.
सर क्या चीज में डिस्कनेक्ट हो गया था बीच में
हाँ
डिस्कनेक्ट हो गया था मैं समझ नहीं आया लाइट चली गई थी ना बीच में लाइट है
ओके तो भाई मोबाइल डेटा नहीं था हाँ हेम
हाँ सर पीसी से कनेक्टेड था
ओ अच्छा तो भाई मोबाइल से हो जाते भाई चलो कहाँ तक थे तुम कहाँ तक समझ मतलब कहाँ तक किए थे
सर इससे पहले थर्टिकल पार्ट लिंक वाला
लिंक लोकल ना हाँ तो लिंक लोकल वाला तो पूरा कर लिए थे तो वही तो बता रहा था कि लिंक लोकल में मतलब कैसे IPv6 ऑटो जनरेट होता है
हाँ सर उसके बाद डिस्कनेक्ट हो गया था
अच्छा तो बस वहीं तक हुआ है अभी तो वही प्रैक्टिस ही कर रहे थे तो वो पूरा किए थे तो कैसे कन्वर्ट होता है
यस सर
हाँ तो बस वहीं तक है अभी तो बस एक क्वेश्चन दिया हूँ प्रैक्टिस के लिए ओके Godson all right had given the answer was it 60 or 80 at the end Okay. All right. What's? I think it was 80. It was 80. Yes, 80. Guys, it's 6:30. I got only 2 answers. What about else? Boris, Philip, what happened, brother?
Hello, working on it.
Are you
Just give me a few minutes.
okay? Sure. 2 more minutes for you guys.
Okay.
Parmeshwar 26047FF. Okay. FE6B3480. Okay. Good. One more minute left. Okay, Stephen 026040. Okay, 47FF FE6B. Okay, right. 30 more seconds. Okay, time up. Now, I think it's a simple, right?
Yes, sir.
Okay. Okay, we had MAC address 006B. Let me copy this. If I can paste it here. Is it possible to paste it in Paint? Him. I'm just repeating it once again. If you had missed, you just check it from here. Okay, very big, very small. Okay, so this was the MAC address, right? Now we have to divide it. The first was we have to divide it into 2 part. So 006047,
47.
then 6B3480. The second we have to insert FFFE in between 006047 FFFE 6B3480. And the third was we have to invert the 7th bit. Okay, invert 7th bit. Okay, so this is 4-bit, leave that as it is. In the second nibble we will have 0000, 4-bit here.
Yes, sir.
In the second nibble 5, 6, 7. So this value we have to invert. So 0 will be inverted as 1, right? So the value would be 8 4 is off 2, so the value will be 2. So 0 2 6 0 colon 4 7 F F colon F E 6 B colon 3 4 8 0. If you will check here on that screen itself, it's given the answer 26047FF, 26047FF, FE6B and 3480. Right? Done?
Done, sir. Yeah, that's accurate.
Philip?
Here now. I was making my mistake. I wasn't converting the 7th bit. That was my problem.
Exactly. So
But I'm
make
clear now.
sure like there's only one thing added here, which is in IPv4 we were working only on decimal and binary, but here we are working on hexadecimal, means every single character is itself a 4-bit. So do not consider that as a decimal, that is a nibble. So it means every single character having 4-bit. Okay, so just think about that. Okay.
Could we try again?
Okay, one more question. Good. So this time I'm giving you from my end, okay? Because in PC it's given here the link local, so everyone can cheat. Okay, so I'm giving you from my end. Mm, okay, the question would be 3 4 F 3 4 F6 colon 4 6 3 8 colon FF39. So this is the MAC address. Now it will be fun. Yes. It's 6:38. You guys have 5 minutes till 6:43. Let me open the chat as well.
Is it correct?
Okay, 36F6. Okay, 36F6. Okay, fine. 46FF FE38 FF39. Absolutely right. Him is also right. Okay. Parmeshwar 36F6. Okay. Good. Parmeshwar also right. FE38, what is, okay, FE38, okay, FF39. Okay, earlier it was misprint. Okay, now Godson FE80. No, brother, I don't think you are right. Okay, you are starting with the FE80. So, brother, like you have to give double colon there to identify the uh, all zeros areas. Okay, so after FE80, it would be double colon, then 36 F6, 46 FF, FE38, FF39. Right. So just give a double colon there. Godson. Else everything is right. Just give the double colon over there. 36 F6, 46 FF. Yes, Stephen is also right. Yes, now it's correct. One more minute, guys. Boris and Philip, I'm waiting for your answer. Messi, you are also not there. Okay, Joffrey here. All right.
That's 6.
30 more seconds, guys. Philip, okay.
That's correct.
3, 4, F6, no. Where have you converted? Where have you inverted? You have not inverted.
Oh my gosh.
All right.
That's the same thing I asked you about earlier. I made the same mistake.
Yes. Okay, so I think time is up now. Boris, your answer is also not coming. Very disappointed.
Sir,
Yes, Boris.
I have an observation from this process so far.
Yes, Godson, tell me.
Um, okay, I can notice that in inverting the seventh bit is same as either adding 2 to the pre-existing number there. The first time we had 0, 0.
Uh-huh,
It
uh-huh,
became 260. Now
uh-huh,
you formulated and gave us 34,
uh-huh.
and now became 36. It's like it can be a constant. Just add 2 to the presiding.
Awesome.
Could it?
Yes. Uh-huh. Exactly, you are right.
Okay.
You are absolutely right. But the thing is that if I am
Okay.
taking here, says, uh, if I'm taking here 8, then it would be
Wrong.
A. No, not wrong.
Okay. Okay. A. Okay. Okay.
A.
Yes. Okay.
If I'm taking
Okay. Yes.
A,
Yes.
it would
Yes.
be E.
C.
E, right?
Okay. Yes. 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 I think yes.
Uh, all right. So let us discuss on that later on. But the
All
simple
right.
thing, let us explain this to the guys who are struggling still. Okay. So this is the MAC address we have. The first step is we have to divide it into two part, right? Now, the first part is 3, 4, F6, 4, 6, and then 3, 8, FF, 3, 9. No confusion in this. The second is just add F, 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 E in between, right? The third part is the seventh bit. We have to invert the seventh bit. If I'm talking about seventh bit, the first nibble we have 4 bit, the second nibble we have 4 bit. So seventh bit will come into the second nibble. So The 4 we can convert it as 0 0 4 0 1 0 0, right? Oh my god, I think
Yes,
no,
yes, yes,
no, no,
yes.
no, no, no. I'm wrong.
What?
I'm wrong. Yes, 0 1 0 0. Yes, correct. So
Yes.
the seventh bit, it's 0. It will be inverted as 1, right? Seventh bit is
Yes.
this. So
Yes.
4 and 2 6.
Plus 2,
So it will
6.
be 3 6 F6 4 6 F. Just give a colon in between. F338 colon FF39. Done. Now, whatever the research is of Godson, it's a very good research. Let us check, is it correct or wrong? Okay. No, it will be very much helpful for everyone if you will get the MAC address, if that will be correct. Okay, if that concept would be correct, you will be taking hardly 1 to 2 seconds to convert the MAC address into.
Yes. Yes, sir.
Okay,
That's true.
right. So let us research on that. What is the research? So if I'm
Other
taking,
Mac
if I'm taking it as 48, okay, 48 FF, okay,
410.
it should be,
410.
it should be,
410.
it should be 4A.
D. A.
It cannot be 10, it could be
Yeah.
A,
4A,
right?
4A.
yes, 4A, 4A, you're correct, sir.
Now if I
4A
convert,
FF.
if I convert the seventh bit, 8 is 1000,
Oh,
seventh is this 1010,
yes.
8 or 2 A,
Okay.
4A. Now the second,
Yes.
let us take 2 or 3 more examples. If I'm taking is 09 AC, okay,
Mm-hmm.
9 plus 2 11 means it could be
B.
11.
B,
B.
0 B AC,
B.
right? Now if I'm taking
Yes.
B, let us convert. 9 means what? 0, sorry, 1001, right? If I'm
Yes.
converting this, 8 plus 2 10 or 1 11.
10. 111.
Yes, it is passed. Good.
So the observation is accurate, sir.
Exactly.
Wow. All
Okay,
right.
so we all learn a new thing today. It is a very good observation. Now any MAC address, let us try with random MAC address. Okay, let us take this one. Okay, this 00 starting 0002, it should be 02 02.
02.
Yes. Okay.
Yes.
uh Rest all like after
Same,
F5,
sir.
after 5E we will enter FF FE. Okay, this fourth thing we have to add. That's it. So it's a very good observation. Good, Godson.
Thank you,
So
sir.
any confusion yet? Any confusion, guys?
No, sir.
It's clear now, right?
Yes.
So it's 6:49 p.m. now. We will stop here today's session. Tomorrow we will come to the uh, configuration part. How to configure uh, IPv6 addresses and how to do the like static routing or routings in IPv6 addresses and all. Okay, so that part we will cover tomorrow. Is it done for today?
Yes, sir. Yes,
Okay,
sir.
sir.
Thank you very
I
much.
hope
We
today's
Yeah,
appreciate it.
session
thank
was
you.
very much informative for all of you and for me as well. I really thanks to Godson for this effort. Thank you so much, Godson, once again.
Thank you
Okay,
very much, sir.
Thank
So
you.
what you will do? So what you will do now is add that to one of your rules now. Increment by 2.
exactly. Just increment by 2, but make sure it would be in hexadecimal format.
Agree.
Okay.
Yeah.
Now, okay, one more thing. Let us check if I will have. Okay, here is one cache. Now, just now I got a question here. If I will have FF39, what will happen? What will happen?
Zero will come. F0 will come, sir.
Okay, let us check. So 110, sorry, 1111.
One
This is what.
one.
Yes, one
So
one one.
1101 means 8, 14 and 1, sorry, 8, 12 and 1, 13. So
13.
it will decrease now.
Decrease. Decrease, sir.
Okay, so if it is full, like if f is there, it will decrease as d, right?
Yes, sir.
Okay, it will decrease by 2 if it's F.
Yes, if it will be e, then also it will be, I think it will be decrease.
It
Let
will,
us check. E
okay.
means what? 1 1
For
1 and 0, right?
0, yes, yes.
So it would be 1 1 0 0.
Yeah.
So 8 and 2, 8 or 4, 12.
12.
12
It will
means
decrease by 2.
C. It will be also E and F will decrease by 2, rest all will be increased by 2.
Okay. E and F decreases by 2.
Yes,
Okay. Y others increases by 2. Yes, yes, that's accurate.
because we cannot go beyond of F, so it will
Yes,
be
yes,
decreased
yes.
by 2
By 2.
and rest. Okay.
Right. Yes, sir.
So as per as of now's observation, this is the scenario, but still we will make more and more research. Once you will practice, you will get more and more research. So this is what I like from my session. This is what I like. I want everyone's observation, and I also want to learn from you guys. So thank you so much once again to all of you for joining today's session. Once again, we will meet tomorrow with practical part. Okay, so theory part is done.
So please share the video, sir, and
Definitely. So, but it will take a little bit time because it's 7 p.m. and it is, I think, 3 hours session. So it will take a long time to render and all thing. So it will take 5 to 6 hours.
Will the time for the class tomorrow be communicated across to us, sir?
Yes.
Will it be the same time?
At the same time, at 4 IST 4 p.m.
All right.
Okay. Any question from today's session?
Yes, sir.
Any question? Yes.
Yes, sir. I have a question. I noticed the types. I noticed the types of IP version 6 addresses. They are not like they work together. It's not like they are divided. I have this similarity. I don't know if it's similarity or different. Is it that like the multicast, they are all in the IPv6? Like, I don't know how to state it, but if I would go through my note and then maybe make reference to that later. When I go through my note, I will organize my question. It's just like pieces in my head. I can't really put it down in writing.
Okay, you just like taken. Oh, just give me 1 second, please. Just give me 1 second.
Okay.
Hello.
Yes,
yes,
hello.
Godson. Yes. So
okay,
I was
two
saying,
questions. Two questions.
Yes, please.
One being in IP version 4, we'll have the classing, like class A, class B. We know that the class D is used for I think class D was used for multicasting.
Yes.
Then class E is for scientific researches.
Correct.
So does that also apply? Do we have this group of IP addresses for, like, are they divided in classes, or these types, is it the form of dividing them in classes? Like, can we say the classes we saw in IP version 4?
No, classes are something different. Here we do not have any classes. These are the types. These are the types.
Then, okay, that my first question is answered then. Then the second one is that, like, the types are confusing me. The types, I'm really confused about the types. Like, how?
Okay. While explaining the types, just blank your mind. Okay, just blank your mind. Do not mess up everything. Okay, just blank your mind now.
Yes, sir.
types, whenever I was explaining you, I was also mentioning the use of that type, where exactly it will be using, right?
Yes.
Unspecified, what is the use? Loop back, where
Honest.
it is use? Global, what is
Yes.
the use? Multicast, what is the use? Link local, what is the use? If you will
Okay.
compare this as a class, it does, it means that you will get only single IP address at a time for every device, but here it's a situation is different.
Okay.
Okay, what is the situation is different? Whenever you will configure one IP address and you will check the IP address of that device, you will get multiple IP addresses at the same time. But in IPv4, if you are giving class C IP address to one device, you cannot give the IP address of class A, class B, every class's IP address at the same time, right? So this is
Yes.
the difference between classes and the types.
Okay. Okay, you're saying that for each IP address in the IP version 6, all the types of IP version 6 addresses can be applied to it.
Exactly. Once we'll come to the configuration part, once I will give any IP address to any interface, I will show you the global IP address you will configure manually. At the same time, it will auto generate a link local address. It will auto
Okay.
getting a group of multicast
Multicast.
group. Okay. So
Okay.
these all will be there at the same time for different
Okay.
purposes.
Okay. Okay, sir. Okay, sir. Then, from the types, you said unspecified is used for multicast broadcast.
Unspecified was yes, for multicast the DSC. Okay, understand. We have
Yes, sir.
a group of devices. Suppose I have, just for example, if I'm connecting a laptop PCs in a network, at the same time I'm also connecting my uh, mobile phones with the same network. Okay, so it will divide with the multicast group. Okay, what kind of devices you are connecting in the network. Okay, according to
Yes, sir.
that it will divide into multicast group. Now after that, if you will uh, if you want to get the IP address, even if you have not configured the DSCP in that network, still if you will
Okay.
request for the IP address, you will get the IPv6 address automatically.
Okay. Okay.
Okay,
Okay.
so
Yes,
once we
sir.
will come to the configuration part, then we will like get to know about these things. So no need to worry. Okay, let us complete tomorrow's session and then we will come into that part. If any confusion still we will have. Okay,
All right, sir. Thank you very much, sir.
thank you so much. Any other questions from anyone? I hope everything is clear now. Like regarding IPv6, me personally, I'm talking about myself. Uh, once, like one point of time, like I was also getting scared of IPv6 address just while looking at 128-bit. Oh my God! In 32-bit, I'm getting hell lot of IP addresses and this much of calculations like subnetting these and this. What will happen in 128-bit? So I was getting scared of this, but whenever I learned about IP, and I took this long time between IPv4 concept and IPv6 just because you guys can get like used to of IPv4 address. If your control on IPv4 address is good, in subnetting in IPv4 is clear, you will not face any difficulties in understanding the IPv6 address. Okay, so it's task for today. Those who are new, those who are old, just revise for IPv4 addresses and the theory part whichever we have completed today. Just revise this once so that once we will come to the practical part, you will not face much difficulties. Okay. All right, guys. So let us complete today's session. Let us close the today's session. And today's session was very much informative for me as well. I hope the same with you as well. So once again, we'll meet tomorrow. Till then, bye bye and take care. Okay. All right,
So this
guys.
video is uploaded, right?
Definitely, every
Evening.
session's video will
Oh,
be uploaded. No need to worry
okay,
about that.
okay. Because I just missed this session and I have joined recently now. Just
Okay, no worries.
uploaded.
Okay. All right, guys. Thank you so much for joining today's session. We will meet tomorrow once again. Bye bye and take care. Okay. I'm just closing the
All right,
session.
thanks.
Thank you. Bye
Thank you very
bye.
much.
Bye bye. Take care.
Thank you very much, sir.